Everyone, I'm back. Today we're going to talk about how can we write a really awesome experiment. We're going to start with this question here. Which type of light conditions is best to grow a spider plant? Of course, you guys know I have some spider plants in the window of my classroom. I have some over here. I've got one right here growing in the center of this plant. So what are the best light conditions to grow a spider plant? If this is my question, the first thing I need to do is I need to be able to identify my variables out of that statement. Now, I'm going to look for what it is that I would be changing and what it is that I might measure or observe to see if those changes are successful or not. There's a clue which type of light conditions are best. So which type of light conditions are best to grow what? What are we growing? We're growing a spider plant. So if I go over here to type of light conditions, that's going to be my independent variable. My dependent variable is going to be my growing of the spider plant. How the spider plant grows is going to depend on the light conditions that I put the plant inside. So my dependent variable is the growth spider plant. What is going to be my controlled variable in this experiment? Well, if I'm designing an experiment and I'm only testing light conditions, everything else would have to be the same. So I know that I'm going to have things like temperature, type of plant, in this case, spider plant, pots the pots and soil that the plants are in, and the amount of water. Anything to do with the growing of the plant has to stay the same, except for the light conditions. If I'm looking at my types of light conditions, I might think about what type of light conditions I might have. Dark, shade, partial light, full sun, artificial light, so if I'm looking for a control group, my base setup, I'm going to be looking at my plant in its usual conditions. In this case, it's going to be a window. My experimental groups are going to be the plants in different spots to see if they grow better in a different spot than I usually have it. So, what might be example? Maybe under a table. Maybe in the corner of a room, so it gets some shade but not any direct light. And maybe I'm going to try it under some artificial light. When I come down here and I create my purpose statement is really, really easy. All I'm going to do in my purpose statement is I am going to take my question and I'm going to flip it around. Again, I'm going to start with the purpose of this investigation. The purpose of this experiment is to determine which light conditions are best for growing a spider plant. So all I really did is I took out that question word which at the beginning and substituted the purpose of this experiment is to determine the light conditions that are best to grow a spider plant. So I changed a couple of the words around and their tense, but for the most part, it's still the same sentence as the question, but now it's just been made into a statement. I'm going to go ahead and, just like before, I'm going to take this purpose statement and I'm going to turn it into a hypothesis. I'm going to make sure that I, again, still mention light conditions and growing a spider plant. Best conditions for growing a spider plant will be, and I'm going to give my answer, will be this because I'm putting my spider plant in different conditions, I need to make a prediction not just about the best, but about what will happen with every single light condition. Because I have in my experimental group 3 experimental groups, I am going to say what I think the best conditions are going to be, what the next best, and what the least will be. The next best will be, I'm going to give my reasoning as to why a certain environment will be the best compared to another environment or the other environment. When I write a hypothesis as an expert lab writer, I need to make sure every experimental group is mentioned in my hypothesis. The next thing I need to do is I need to plan my investigation. Now I have some idea, right, with my variables, but now I really need to get into my materials. The first materials I'm going to start with are the materials that I'm going to have for every single setup. I'm going to start with my controlled variables. So what are the things that I'm going to need? Of course, I'm going to need spider plants. But let's be very, very specific. We know that we have to keep everything the same about the spider plants. So let's mention the size pot that they're in. Spider plants in 4-inch pots. Now, how many spider plants am I going to have? For every experimental group, I'm going to want to have 3. For every control group, I'm going to have 3. I want to have at least 3 trials for every group that I have. So for my control group in the window, I'm going to need 3. For under the table, I will need 3. For artificial light, I will need 3 more. And for under a grow light, in the corner, I will need 3 more. So I will need a total of 12 spider plants. Notice that I'm giving specific amounts and specific sizes. So 12 spider plants in 4-inch pots. The next thing I'm going to need is I'm going to need a ruler, of course, to measure. For my materials, I also need my locations. I'm going to mention my locations because those are the things I'm changing. They are part of my materials. And I'm going to put my locations for my plants. Window, grow light, corner, under a table. Of course, in order to do the experiment, I have to have these locations available. I have to let the person know who might replicate this experiment exactly where I'm going to put the plants. My procedure. When I write my procedure, I'm going to write it just like a recipe. I'm going to give them steps 1, 2, 3, 4, 5. I'm going to give very specific, detailed steps in my procedure. I will start with first, before we do the lab, right? What are we going to do first? We're going to measure the height of all of the plants. Measure and record the height of each plant. What are we going to do then? We're going to start to set our lab up. The first thing I'm going to do is I'm going to start by setting up my control group. Place 3 spider plants in the window. Place 3 spider plants under the grow light. Place 3 spider plants in the corner. Place 3 spider plants under the table. Now that we've placed them, now we have to think about what are we going to do? How long do we want them to be in those conditions? How are we going to maintain those plants while they're in those conditions? So of course we have to water the plants, but we have to make sure it's consistent. Water the plants with 20 milliliters of water every 3 days. I'm going to be very specific about the amount of water that I give the plants and how often I give the plants that water. Again, this is going to be a controlled variable, so I want to make sure that I'm showing that I'm going to be consistent. Now we have to decide when and how often we're going to measure. So let's go measure the height of each plant every 5 days. Record the results in the data table. We're going to measure the height of each plant every 5 days. Now I can start to move on to my data table. In my data table, I'm going to make sure that my columns that go across the top are going to allow for enough measurements. And I'm going to make sure that I have my rows are going to represent my spider plants. Okay, so we've got our independent variable, which is our locations, and we're going to have our time intervals across the top. So let's go ahead and let's insert our data table. As I insert my data table, I'm going to make sure I have 12 plants, so I'm going to go 13 rows because I need to have a title. And I'm going to measure my data for 20 days. So 5, 10, 15, 20, and then I'm going to have a place for my results at the end. So what do we have here? I'm going to have my starting height, five days, 10 days, 15 days, 20 days, and I'm going to put in one more column, or I'm going to say my total growth. I'm going to have window 1, make this smaller, window 1, window 2, window 3, and then I'm going to have my plants from each of the other locations, and I'm going to continue through till I fill in my data table. Now I have an excellent data table that I can record my starting height, 5 days, 10 days, 15, and 20. Now, does my data table match my results, match my procedure? Sort of. I'm going to go back and I'm going to add something. Measure the height of each plant every 5 days for a total of 20 days. I'm going to add that little piece so that my procedure and my data table match up. This is how we can set up an excellent lab. Now, you will be doing the same thing with the Gummy Bear Lab. As you open up the Gummy Bear Diffusion 3.0s, your job will be to choose one of the questions and design your own lab around that question. Keep in mind all the things that you need to have to design an excellent lab. You can do it. See you soon.